Okay, so today we are going to do that one question that will be on the diploma. Okay? They always put an application question. One application question. Okay? So it's going to be either the Richter scale or the decibel scale or pH. It'll be one of those. Now, the pH seemed to have been quite identifiable from those who took chem, and people were like, oh, that's how it works. Okay, so you were using it, but you kind of didn't know what you were doing. You're just putting stuff into here. Now, the nice thing about having brand new books is you actually get up-to-date information. Today is actually the anniversary, 2-year anniversary of that earthquake. And as you can see on the whole magnitude scale, that one's up there. Okay, almost the biggest one in history. And they're, today they said they still haven't built around the main area. The big reason this one was quite a fear is because they had a nuclear power station that. Any of you guys ever been in an earthquake? Yeah, where? How? What size? Yeah, still weird though, eh? It's hard to. I've been in an earthquake in Japan, and it's weird. Like, I've heard people describe that there's kind of things in life that you go, that's just always the way it is, right? And the one thing that you have grown up with your whole life is that the earth is pretty stable, that your house doesn't shake, right? And, we've been beside a train, going, or a subway, and there's kind of a little shake in the car or whatever. If you're in your vehicle and you're stopped at a train that's going by, you can feel the vibration a little bit. But when things are going so you can't really even walk, it's weird. And because I guess the one thing we count on is kind of that the earth isn't going to move on us when we walk, right? But another thing, the one I was in is probably like a 1. Who knows? I don't know. It wasn't enough to even make the news kind of thing. But I was around some little kids at the time, and they just got that was just like fun, right? Because they had been, if you live in Japan, earthquakes are just part of the deal, right? Because it's by a fault line. Same thing with Vancouver. Vancouver, they're just waiting. They have done, probably in the last 20 years, they have tried to earthquake-proof that entire city, right? And they've I know they're big. They have one building that actually, when it's windy enough, it actually sways in the wind, like when you're up there, because they tried to build like a tree. And trees do very, very well in earthquakes, okay? Because they have a center and they're able to move. Anything that's not able to move, like bricks do the worst. Brick buildings do the worst in earthquakes, where wood ones do better, okay? Wood gives a bit. Bricks don't give too well, right? Anyway, whenever someone says that is a magnitude 9, that actually means it has a power of 10 to the 9th power. It's 10 to the 9th. Now that's big. Okay? Oh, another thing about trees, why they do well, is because they have a root system, right? So they've built all those anchors and everything into their big buildings. And they've got to be ready, like airports got to be ready, right? So my stepfather, actually, he was in charge of all of the air control centers for Canada. And it's really weird. I always picture guys up in a tower, right? And they're doing, but everybody is underground. There's only one guy, the guy in the tower, he's doing visual stuff, but it's like 1, 2 guys. They're all underground, right? And they've got all these like what I considered was pretty outdated computers. I couldn't believe the crap they have, right? Most all of you have better computers than they're working on there, and they're doing everything. They have every plane and the whole thing, and they're doing it all underground. Well, when you're underground, you got to make sure that when an earthquake comes, so they had to redo all the ceilings, everything, right? Because you don't want to shut down all your air travel as soon as you have an earthquake. So it is something that everybody's got to deal with. Being in Alberta, it's something we don't have to deal with, right? We put up with snow and tornadoes, right? We get our tornadoes once in a while, but you don't have to worry about earthquakes. So as you can see, anything about a 5.5 up would be considered devastating to cities, because another thing that probably does the most damage is fires during earthquakes. And like you're thinking, how does like the earth moving create fires? Well, every house has a gas line going to it, and one person or one place, it has some type of flame going somewhere, be it furnace, whatever. Well, when your house moves like this, pipes snap. Okay, now you got a gas line that's just going like crazy all over the place, and a little bit of a flame, and you can see why your house goes up pretty quick. So remember when I say magnitude 8 is how many more times more intense than magnitude 7, I'm saying it's not 1 times bigger, because you're like, well, yeah, it is 8, 7, 1, because this means 10 to the 8, and this means 10 to the 7. So when I want to find out how many times bigger something is, you always put it in ratio. That's 10 to the 8 over 10 to the 7. That's how many times bigger something is, which is 10 to the 1, which equals 10. So it is 10 times bigger. Now, if you have something magnitude 7, how many more times is intense? Now think about intensity. How much more intense than a 3? It's just 10 to the 7 over 10 to the 3, which equals 10 to the 7 minus 3, right? I guess I should have put that over here, which is 10 to the 8 minus 7. Remember, when you divide powers, you subtract the exponents. So this is 10 to the 4, which is 1 with 4 zeros, right? 10 with 4 zeros. So 10 to the 4 is 10,000. Okay, how many times more intense would an earthquake 4 be than an earthquake 6? See, and you want to kind of do it, that's 10 to the 4 over 10 to the 6, which is 10 to the negative 2. Yeah, so that's 10 to the negative 2, or 1 over 1,000. Well, 100, sorry. 10 times 10. Okay, and let's just do D. The 4.8 is how many more times 10 as a 6.8? Be the same, 10 to the negative 2, or 1 over 100. So if the smaller earthquake is first, just think of the division, it will give you a negative exponent. Okay? So when you get the diploma, they'll put the formula down for you. Okay? So they might have this formula. Now, this is a fancy way of saying intensity 1 over intensity 2 should equal magnitude of 1 over the magnitude of 2. Or I should say 10 of the magnitude of 1. 10 over the magnitude of 2. Now, do you see where we get the 10 to the m1 minus m2? So how many more times is intense? The 1960 was 9.5, then the earthquake, which is 7.8. So in order, it is 10 to the 9.5 over 10 to the 7.8. This is going to give me my intensity. If you do the math, you get 10 to the 1.7. If you take 9.5, subtract 7.8. So it is 50 times. So if it's got a magnitude of 9.5, it's 50 times as powerful as a 7.8. Okay. Now, we got an earthquake of magnitude 7.5 is 375 times more intense. Now, when you do this, you want to go big over little equals big over little, right? Always keep them on the same level. Now, if it's 300 times more intense, the big is 375 more intense than the little. So when they don't actually give you the intensity, they kind of have. And then the big is 10 to the 7.5, and the little is 10 to the x. So ratios really make these make sense. Formulas are great. We all love them, right? But kind of thinking about it doesn't hurt either. Now, there's two ways to do this. Okay. The first way is cross multiply. Okay, so you're going to cross. So that'll be 375 times 10 to the x equals 10 to the 7.5. The other way would go 375 equals 10 to the 7.5 minus x. Actually, so this one I actually wouldn't do two ways. I would just do, so you can cross that out. We'll just do the log way. Okay, now this one, we have our base, right? And we have an exponent we don't know. That's where this has all come to. How do I find that? So I will log it, right? So log 10 of 375 equals 7.5 minus x. Now, if I was to do this without touching my calculator yet, that would be log 10 of 375 minus 7.5 equals negative x. Now, again, without using my calculator, I'm going to I have to multiply both sides by negative 1. So negative log 10, 375 minus 7.5 equals x. Now, we're always going to try and get it, so we're going to try and get it so we are all set up before we hit our calculator, because this may be the answer on the diploma. Now, the reason why this could be the answer is this one actually tests, do you even know how to make this x equals without using your calculator? Right? And it is more of an intimidating answer. Oh man, I got to find that thing? Well, that means I got to go back and do all the algebra. Okay, so this one you could see is a little higher level than y1, y2, or whatever, right? Now, what are we getting as an answer? 4.9. That is the magnitude of that earthquake. Okay. Next one. The decibel scale. Now, you may have heard of Alexander Graham Bell. He invented a couple things. Most importantly, he invented the telephone, right? And the telephone makes noises. So they're like, okay, you did a pretty good thing. So we're going to name our loudness scale after you. It's a pretty good legacy. So when we do our exponents, always do it in bells. Now, if you have a decibel scale, which you've probably never heard of stuff in bells, it's always been decibels, right? Because decibels are whole numbers, right? Whereas if you dealt in bells, I'd be like, yeah, that's a 12.2, or, 10 to the 12.2. It's always decimals. Where the decibel scale kind of goes off of 0 as a threshold of hearing. Now, we do base hearing on what we hear. Okay? So that's actually done to human beings. They didn't do this to dogs. They didn't do it to anything that has sharper hearing than us. So 0 is the threshold of hearing. Now, there used to be, like I remember last year, it's kind of a fallacy, but there's an app on your phone that kids are supposed to be able to hear that adults can't. You ever heard that? Or a ringtone or something like that? And that's probably, well, it's not true. My whole life, I've always had very, very good hearing, and I always play my music loud. I always, right? And they always say, oh, you're going to wreck your ears, the whole thing. But it depends on, obviously, your hearing, not your age, right? It's kind of like, same with sight. Some people 5 years old wear glasses. Some people 50 do not. Okay, so it's based on, obviously, many other factors. This gives you an idea of where everything falls, okay? Your jet engine is the highest one on here. It's about 135 decibels. Leaves rustling, whispering, you can see how low it is, okay? Now, when something is 150 decibels, it is actually 10 to the 15 is actually the true loudness. So, you can see right there, we had to use bells for, and that's what you're always going to convert everything to. So 120 decibels, how many more times as loud is that as a dial tone? Okay, so this is 10 to the 12, and this is 10 to the 8. So then you go 10 to the 12 over 10 to the 8 is 10 to the 4. Okay, which is 10,000. So it's actually 10,000 times as loud. Okay? Now see, a whisper is how many more times as loud as a conversation. So whisper is 10 to the 3. Conversation is 10 to the 6. So 10 to the 3 over 10 to the 6 equals 10 to the negative 3, which is 1 over 1,000. So it's actually 1 over 1,000 times as loud. So, you go to the next page and you get to see the scary formulas. Okay? Now, well, I'm going to show you how to do this in an example here. This is decibels, 10 log I over I naught. Bells are just log I over I naught. So I just convert everything to bells as I do this stuff, and then I don't even have to do this formula. But if you want to put it in, you can. Now you do not have to memorize these formulas. They will be on the diploma. Okay. Um, let's do examples 5 too. Okay. So example 5, it says, show that this, when I put this into here, equals this. So put this into here. So I would have 125 equals 10 log I over I naught. My goal, make it look like this thing here. Okay, well, so what should we do first? Divide by 10. And then you're basically in bells. So it's I over I naught. Okay, what do we do next? Can I put this into exponential form? But I don't have a base. There's a 10 there, good. Okay, so then I would get 10 to the 12.5 equals I over I naught. And then I would multiply both sides by I naught. So you'll get I naught. Now the numbers always go are 10 to the 12.5. I naught equals I. Okay, this is a great question. You have two telephones in a home that ring at the same time with a loudness of 80 decibels each. Does this mean that the total loudness would be 160 decibels? No, it doesn't. Okay, now this is kind of a loaded question. You can tell by the way they're wording it. So I just want you to know this sentence. Twice as loud. Now another word for loud is intense. Does not equal twice the decibels. I'll just put dB. I mean, if you go back, I mean, it's pretty safe to say that two telephones ringing would not be louder than a jet engine in your living room. Okay? But the question would be, well, what would be the decibels for something twice as loud as a phone? One phone, two phones, right? So, again, if one person's singing, another person starts singing, it does become twice as loud. But it does not become twice the decibels. Okay? So, well, I'm going to prove it. My formula, well, intensity 1 over intensity 2 should be 10, or I'm going to put 10 to the magnitude 1 over 10 to the magnitude 2. Okay, now, what numbers can I put in here? Okay, since it's twice as loud, that would make this 2 and this 1. That's twice as loud, twice as intense. Now, two phones together, I don't know. I'm going to call this X. But I know that one phone by itself is, that's an 8. So basically I will have 2 equals 10 to the X over 10 to the 8. Or 2 over 1 if you... See, I have them on the same level. This is the one telephone is 10 to the 8. Two telephones is 10 to the X. Does that make sense? Okay. Now, 2 times 10 to the 8 equals 10 to the X. Okay. Now, we can just leave it as 2 times 10 to the 8. It's like scientific notation, right? But that's how that's made. Now, we can do the log of 10 times 2 times 10 to the 8 equals, what do we get? Yep, 8.3 bells, which is 83 decibels. So 83 decibels is twice as loud as 80 decibels. Okay, not what a lot of people would expect. But remember when we did that earthquake was 375 more times intense. We had 375 over 1. You can see that the exponent changes very little. Okay. Last thing, pH. Now this gets kind of confusing because of words that can be used. Now, the way the Richter scale works is 0, we always think of a strong acid, that should have a big number. But in the pH scale, 0 is the strongest acid you'll ever get. 14 is a crappy acid. So, this is where you would have strong acid. On the other end of the side, or where strong acid is, we would have a weak base, right? Battery acid is a very weak base. But 14 is a very strong base. So this is where you would have a strong base or strong alkaline. Alkaline is a synonym for base. Alkalinity. If it has high alkalinity, has a high pH. And this is neutral, okay? So 7 is the middle. I know anyone that's been in chem, this is total review for you, right? Now, what we have to do, we have two things to keep on track on this one. It's what are the words used in the sentence and what would be, what side would I be thinking of it from? Okay, so let's look at tomato juice is how many more times as acidic as pure water? Now, is tomato juice more acidic than water? Now, pure water, that's a 7, right? And tomato juice is a 4. Okay, now, if you did this, you would go 10 over 4 is 10 over 7. You're going to get 10 to the negative 3. Now, here's the weird thing. It's like, how do you keep this straight? You actually have to understand that if it's more acidic than the other one, okay, you will always say that this is 1,000 or 10 to the 3. It's 1,000 times more acidic. If this was basic or alkaline, then I would have 1 over 1,000. Okay? So you really have to think about this one because it does get weird. It does get confusing. Now, eggs are how many times more alkaline than water? Now, are eggs more alkaline than water? Yes. So you'll have a number over 1. Okay? So eggs are, what are eggs? What's the pH? 10 to the 8. And water, 10 to the 7. So 10 to the 8 over 10 to the 7 equals 10 to the 1. So eggs are 10 times more alkaline. I would just write this sentence down underneath. Eggs are 1/10 times as acidic as water. Both those sentences means the same thing. So this one really plays with your mind here. Let's do E. So E is eggs are how many more times alkaline as washing soda? Now, are eggs more alkaline than washing soda? No. So we should have a fraction. So eggs are 8, 10 to the 8. Washing soda is 10 to the 12. So you have to think, am I going to make this a 10 to the 4 or 1 over 10 to the 4? So eggs aren't more alkaline, so it should be when we get 10 to the 4, that's 10,000. So we're actually going to put 1 over 10,000 here because we have to think about it. If I was to rewrite this, I could also say eggs are 10,000 times more acidic than washing soda. Okay, so we got to watch out for those ones. Okay. Now this is the formula that anyone has been in chem. pH equals negative log H plus. Hydrogen concentration. Remember, it's expressed in moles per liter. Okay, so we're going to do example 10 and 11 to show you how this works. Patient gives a urine sample which should be found pH of 5.7. What's the hydrogen ion concentration? Okay, well, let's just fill everything in. pH is 5.7, and this equals negative log H plus. Now, the first thing we need to do is divide by that negative, right? So negative 5.7 equals log H plus. How are we going to find out the hydrogen concentration? Put it in exponential. So that would be 10 to the negative 5.7 equals H plus. What do we get? You should get 1.995 times 10 to the negative 6, right? So that is 2.0 times 10 to the negative 6 moles per liter. Now, when you were doing this in chem, were you changing it to exponential? You would anti-log? Yeah, it's funny. An anti-log is exponential. An anti-exponent would be a log, I guess. Antifreeze. Ist du thaw? Just saying. Okay. Determine the pH of a solution. It's the nearest tenth. Okay, so it's just a matter of putting it in. So pH equals negative log 3.4 times 10 to the negative 4. What are we getting? .5. Okay, so we're doing 1, 3 to 8, 10, and 11.